Hello students, we are going to learn fractions in this video. Let's start with the definition, which says a fraction is a number representing a part of a whole, and the whole may be a single object or a group of objects. As you can see on your left, there are examples of a full orange and half of an orange, then a complete circle, half circle, a glass full of half full, and the next is half watermelon. So these are the examples which we can see in our daily life where we are using fractions. And the very nice example is given on your right side where a complete whole apple is given, which is representing 1. If you cut one slice out of it, then you are left with 3 by 4 of an apple. If you cut half, that is half of an apple. And if you're left with only one slice, that is 1/4 of an apple. Now, types of fractions. We have three types of fractions: proper fraction, we have proper fraction, improper fractions, and mixed fractions. As the name suggests, these are proper fractions. Proper fractions where denominator is greater than numerator. For example, we have 7 by 8, 5 by 9, 11 by 13. So these are all examples of proper fractions. The other type is improper fraction. Improper fractions are those where your denominator is less than your numerator, basically reciprocal of proper. So the examples are 8 by 7, 9 by 5, and 13 by 11. I've just reciprocated the proper ones. And the last is mixed, which are combination of a whole number and a fraction part. So in this case, basically all improper fractions can be written into mixed, like 8 by 7 can be written as 1, 1 by 7, where 1 is a whole number, and this is a fraction part. Similarly, you can have 9 by 5 as 1, 4 by 5. 13 over 11 can be written as 1, 2 by 11. So that's how we can write types of fractions. Now, let's learn about equivalent fractions. Each proper or improper fraction has many equivalent fractions. To find an equivalent fraction of a given fraction, we may multiply or divide both the numerator and the denominator of the given fraction by the same number. Like you can see in this, it is written 2 by 2. It is written 2 by 2, which has become 4 by 4 when we have multiplied both numerator and denominator with 2. 4 by 8 is being written as 1 by 2 as its simplest form. 3 by 4 is being written as 6 by 8 when we have multiplied numerator and denominator with 2. Similarly, 2 by 3 has become 6 by 9 by multiplying numerator and denominator both with 3. 4 by 12 has become 2 by 6 when we have divided 4 and 12 both by 2. Similarly, 1 by 5 has become 2 by 10. So in these cases, basically we are multiplying and dividing by the same number to get an equivalent fraction. We can have more examples. Suppose I have 4 over 12 and I want to write equivalent fraction of it, then simply I need to multiply with the same number in the numerator and denominator both. Suppose I'm multiplying with 4. So my equivalent fraction will become 16 over 48. And the other example I can take of 2 by 12, where I'm going to divide by the same number to get my equivalent fraction, and I'm dividing it by 2. So I'm going to get 1 by 6. Both of these numbers are equivalent fractions. Now, representing fractions on a number line. Whenever we are representing any number on the number line, then first thing which we need to keep in mind, and especially for fractions, that between which two whole numbers that fraction will lie. As in the first example, the gap of 0 to 1 is given, and in between, in the second figure, it shows 1 by 2 is coming exactly in between. So what is happening? The gap between 0 to 1 is being divided into two halves. When we are representing 1 by 4, 2 by 4, 3 by 4, 4 by 4, then we have divided the gap into 4 equal parts. And for the next one, in 8 equal parts, and for the next one, in 16 equal parts. So what is happening between them? This one thing is very common, that the denominator of the numbers and the parts you are dividing in is actually same. That can be done with the help of an example too. Let's show drawing fractions on the number line with the help of an example. Let's take two examples, namely 3 by 4, and the second could be 7 by 4. First of all, we are going to draw a number line. A number line, now on the number line, we are going to write 0, 1, and 2. Whenever we need to plot 1, 2. So whenever we need to draw a fraction on a number line, then two things we need to keep in mind. Where between which two whole numbers the fraction is lying. So since 3 by 4 is less than 1, so this is definitely going to lie between 0 to 1. And the second is to look at the denominator. Since the denominator is 4, so the gap between 0 to 1 is to be divided into 4 equal parts. That is 1 by 4, 2 by 4, 3 by 4, and 4 by 4, which is equals to 1 only. Now the number which we are looking for is 3 by 4, which is here. Similarly, we are going to locate 7 by 4 on the same number line. Now 7 by 4 is actually an improper fraction, which can be written as 1 3 by 4. What does that mean? That this is definitely more than 1. So 7 by 4 is going to lie between 1 to 2. The second thing is denominator is 4. So the gap from 1 to 2 is to be divided into 4 equal parts. 1, 2, 3, and 4. Since it is more than 1, so the counting and the parts are going to start from 5 by 4, 6 by 4, 7 by 4, and your 8 by 4 is actually 2. And the number I'm looking for is 7 by 4. That's how we can represent fractions on the number line. Now case 3, where we have numbers. The example I'm going to take where neither numerator is same nor denominator is same. So in case of this, what we are going to do is we have 2 by 9, 7 by 12, 3 by 18, and 15 over 36. So in case of this, we are going to take LCM. LCM method is useful in this case because we cannot compare neither on numerator nor on denominator basis. So the LCM of 9, 12, 18, and 36 we are going to write. So the LCM of 9, 12, 18, and 36, we're going to take it as 3 3s are 3, 4s are 3, 6 are This is 312, then 3 ones are, then 3 twos are, and this is 3 fours are. Then with 2 twos are 1, 2, and then we have one more 2. So that's how it is going to be compared. So the LCM of these numbers is 2 into 2 into 3 into 3, that is 36. So the denominator of all these numbers, we are going to bring them to 36. And what exactly we're going to do is 2 by 9. What number I should multiply this to get it 36? With 4. This one is 4, that is 8 over 36. Then 7 by 12. So this is 3 with 3, that is 21 over 36. Other number is 3 over 18, that is 2. 6 over 36. Then the other one is 15 over 36. It is already 36. So we need not to multiply. Even if we need to multiply, we can just multiply it with 1, because that won't change the exact fraction. Now we are going to write them in ascending order. So let's write them in ascending order. So the ascending order, which one is the smallest? This one. So 6 over 36. Then we have next 8. 8 over 36. Next to it is 15 over 36. And the last one is 21 over 36. So the that's how we are going to write these numbers in the ascending order.